So what if I told you that having a warehouse just, packed to the ceiling with backup inventory isn't a sign of a robust or wealthy company?
Right, which is what most people naturally assume.
Exactly. But it's actually a glaring indicator that your entire system is fundamentally broken.
It's a huge paradigm shift for a lot of businesses.
It really is. So welcome to today's deep dive. We are looking at why the pioneers of modern supply chain consider excess inventory to be, quite literally, evil.
And we're pulling this directly from the APC CLTD learning system today.
Yeah, that's the gold standard certification in logistics, transportation, and distribution. Specifically, we're unpacking Module 9, Section D.
Right, which is all about coordinating digital transformation and continuous improvement.
And the mission for this deep dive is exploring how the world's most efficient organizations survive and thrive, really by balancing two radically different tools.
I love the analogy you usually use for this.
Oh, yeah. So for you listening, think of improving a system kind of like owning a house. On one hand, you have massive, sweeping, tear the house down overhauls, the sledgehammer.
It's a big disruptive project.
Exactly. But on the other hand, you have the daily incremental baby steps, the wrench. Sometimes you just need to fix a leaky faucet.
And in the professional logistics world, we formally call those two things digital transformation and continuous improvement.
Sledgehammer and wrench.
Right. Because if you only swing the sledgehammer, you just exhaust your organization with endless, chaotic disruption. I mean, you burn your people out.
Yeah, nobody wants their kitchen rebuilt every 6 months.
Exactly. But if you only use the wrench, you end up perfectly optimizing an outdated system. It's like putting a beautifully polished brass faucet on a sink with totally rusted out pipes.
That makes total sense. You really have to know how to coordinate both to build a truly resilient supply chain.
You do.
So let's start with the sledgehammer, because the term digital transformation gets thrown around in boardrooms so much that I feel like it has almost lost all meaning.
Oh, it definitely has. It's the ultimate corporate buzzword right now.
Right. Like a company buys a ridiculously expensive piece of cloud software, forces everyone to log into a new portal, and management declares they have been, digitally transformed.
Which is usually a disaster. Purchasing software without fundamentally redesigning the underlying human and mechanical processes is, well, it's just funding a very expensive failure.
Ouch. Yeah.
But the text from the CLTD module actually separates this evolution into distinct progressive stages. That way we can stop confusing software upgrades with actual transformation.
Okay, so what's the baseline?
The baseline is just digitization. That's simply taking a physical object and creating a digital representation of it.
Like scanning a paper bill of lading and turning it into a PDF.
Precisely. The process hasn't changed at all. You're just moving from a steel filing cabinet to a hard drive.
Okay, that's step one. What's next?
The next stage up is digitalization.
Which sounds identical, but I'm guessing it's not.
Right, it's a subtle difference. Digitalization is taking a process that humans were managing manually and putting it online to accelerate it.
Like moving from paper shift schedules to a web portal where employees can swap shifts.
Exactly. You are speeding up a human transaction.
Yeah.
Then, the next step is automation.
The robots.
Yes and no. Automation is where you redesign that digital transaction to completely omit human intervention. The system executes the task autonomously, except for handling really bizarre exceptions.
But wait, even an automated warehouse where robots are pulling pallets off shelves in the dark, that isn't true digital transformation, right?
No, it's not, because automation is localized. True digital transformation, which the industry often calls Industry 4.0, is a massive cultural and network-wide shift.
Okay, so how is that different from just really good automation?
Because it moves an organization away from a traditional linear supply chain. Where information slowly trickles from the supplier, eventually to the manufacturer, then to the distributor, and finally to retail.
Like a game of telephone.
Exactly. Digital transformation turns that line into an orchestrated, dynamic network.
So what does that look like in practice?
Say a customer buys a custom product in a retail store. That single demand signal instantly feeds into the planning system of the raw material supplier halfway across the world.
Oh, wow. So the entire network breathes together in real time.
Yes. Everyone sees the same data at the exact same moment.
But if that orchestrated network is the destination, how does a legacy company even map the route? I mean, you can't just draw a straight line from a 1990s legacy database to Industry 4.0.
No, you definitely can't. You have to run what's called a maturity assessment.
A maturity assessment.
It's a brutally honest diagnostic of your current functionality. The text focuses on a framework called the Digital Capabilities Model, or DCM.
And that's designed specifically for supply networks, right?
Exactly. It prevents companies from just buying random tech by forcing them to assess their capabilities across 6 interconnected areas.
So when we talk about assessing a capability through the DCM, what does that actually look like on the ground? Give me an example.
Sure. So one of the core capabilities the model evaluates is the connected customer.
Which is more than just having an e-commerce website.
Way more. A high maturity level here means you have created a seamless data experience throughout the entire customer lifecycle.
From the first click to the final delivery.
Right. Another capability it checks is dynamic fulfillment.
Okay, what is that?
It's about agility. How fast is your order fulfillment when a disruption occurs? Like if a port suddenly closes, can the system autonomously reroute a shipment without a human intervening?
I see. So the DCM helps organizations visualize these capabilities like a web.
Exactly. You identify the specific nodes in that web where your maturity is too low to support your business strategy, and you target your investments right there.
That makes sense. But we can talk about these elegant models and capability webs all day long, but the friction of reality always comes down to the human element.
Always.
The text points out that these massive sledgehammer projects usually fail, and the top reasons have literally nothing to do with the software itself.
It's almost always human or structural. It's unaligned organizational culture, catastrophic master data, and a workforce that is terrified of obsolescence.
Let's talk about master data first. That sounds incredibly dry.
It can be dry, but it's the foundation of everything. Master data is your core information, product dimensions, customer addresses, supplier lead times.
Okay.
If that data is inaccurate, automation just means you're going to execute the wrong tasks at the speed of light.
Right. You're just making mistakes faster.
Exactly. But you mentioned culture, and cultural resistance is really the silent killer of transformation.
Because if workers believe this new orchestrated network is just an algorithm designed to replace them,
They will ensure the project fails, actively or passively.
which means change management can't just be an all-hands meeting where an executive points to a graph and says, this transformation will boost our profit margins by 15%.
No, the floor worker doesn't care about the corporate margin.
Right, they care about their mortgage and their daily friction on the job. You have to communicate how the technology improves their specific reality.
The transformation has to provide intrinsic motivation. If the technology is going to eliminate manual data entry, you have to show the worker how they will be elevated to a more analytical, less tedious role.
And if roles are fundamentally changing, you have to address the fear of job loss head-on with clear retraining pathways.
You must. Ignoring the fear doesn't make it disappear. It just turns it into resentment.
So assuming a company has done all that hard work, they have clean master data, the culture is bought in, they know where their capabilities are lagging, they still need a framework to actually execute this redesign.
Right, and that's where the CLTB text brings in Lean and Six Sigma as the critical methodologies.
Let's unpack Lean first. It originated from the Toyota production system, right?
It did. And its entire philosophy centers on the relentless removal of waste and the absolute simplification of processes.
So what's the ultimate goal of Lean?
To make only what the customer wants, exactly when they want it, with perfect quality and the shortest possible lead time.
And waste in the Lean methodology is incredibly specific. It's not just, throwing away scrap metal.
No, it's defined as anything that doesn't add value from the customer's perspective.
The text uses this acronym, Tim Woods, to categorize the 8 forms of waste. I don't want to just list them all like flashcards for you listening, because some are pretty obvious.
Right, like transportation, which just means moving things around unnecessarily, or defects, which is just rework.
But the ones that always stand out to me are overprocessing and skills.
Oh, overprocessing is a fascinating blind spot for a lot of companies.
How so?
Well, it means using higher grade materials or tighter tolerances or more complex finishing than the customer actually requires or is willing to pay for.
It's engineering for the sake of engineering.
Exactly. Not for customer value.
And then there's the S in Tim Woods, which stands for skills. That's about underutilizing human potential, right?
Yes. Having a highly trained master welder doing basic material handling all day is a massive waste of intellectual capital.
Which brings us back to that provocative hook at the start about inventory, because in Tim Woods, the I stands for inventory.
Yes, it does.
And Shigeo Shingo, one of the brilliant architects of the Toyota production system, he famously declared, "Inventory not in motion is evil."
It's a strong statement, but in traditional manufacturing, Inventory is treated as an asset on the balance sheet.
Right, something you want more of.
But in lean, inventory is seen as a blanket used to cover up system deficiencies.
A blanket. I like that.
Think about it. If your quality control is terrible, or your machines are always breaking down, or your suppliers are always late, what's your natural reaction?
You stockpile backup inventory.
Yeah.
Just in case.
Exactly. That way, the end customer never feels the disruption. But lean demands that you remove that inventory blanket.
Which sounds incredibly stressful.
It is. The philosophy dictates that you should feel the pain of the breakdown immediately. That forces you to actually fix the root cause, rather than just buffering against it with a warehouse full of safety stock.
But wait, if we rip the inventory blanket away and run a pure pull system, where we don't build a single item until the customer demands signal pulls it through the network, aren't we building a glass cannon?
A glass cannon.
Yeah, it's highly efficient but incredibly brittle. I mean, look at the supply chain collapse during the COVID-19 pandemic.
That is the perfect example.
Companies that ran perfectly lean systems suddenly had empty shelves the second a disruption hit their raw materials.
The pandemic absolutely stress-tested the extremes of lean. And the CLTD text addresses this exact tension. A pure lean system with zero safety stock is indeed highly brittle.
Because if one link snaps, the whole thing goes down.
The entire orchestrated network paralyzes. Conversely, a complex supply chain bloated with safety stock is highly resilient, but it ties up massive amounts of working capital and drives up storage costs.
So how does a supply chain architect actually balance agility with resilience?
By meticulously locating what we call the push-pull frontier.
Push-pull frontier.
Right. Very few networks are purely one or the other. They are a hybrid. You push inventory based on historical forecasts up to a specific node in your network, maybe a regional distribution center.
Okay, so that's your buffer.
Exactly. But from that point forward, you wait for a real-time customer demand signal to pull the product the rest of the way.
So locating that exact frontier, pushing it as far upstream as possible without risking stockouts, that's basically the defining challenge of supply chain design.
It is the ultimate balancing act.
And if you are relying on a pull system to move things downstream, the pacing has to be flawless. You can't have one machine working twice as fast as the next one, or you just build up a localized pile of inventory.
Which is another form of waste. And the text describes the mechanism for this pacing as takt time.
Takt time, T-A-K-T.
Right. Yes, takt is a German word for baton or rhythm. It is the mathematical ratio of available production time to the rate of customer demand.
So if the market demands 1 unit every 2 minutes, your takt time is 2 minutes.
Exactly.
Yeah.
And every single station on your production line must be calibrated to complete its task in exactly 2 minutes.
What if a station works faster?
It creates the waste of overproduction, and if it works slower, it creates the waste of waiting. Takt time is basically the metronome of the factory floor.
But if every station is marching to a 2-minute metronome and you have stripped away all your buffer inventory, man, a single defect will shut down the whole line.
It will.
That implies lean is heavily reliant on flawless quality control, which brings in another core lean concept from the text, Jidoka.
Jidoka. It translates roughly to automation with a human touch.
Okay, what does that actually mean?
It is the architectural capability to stop a production line the exact millisecond a problem occurs. Think of the famous andon cord in a Toyota plant.
Oh, right, the cord anyone can pull.
Exactly. If any worker spots a defect or a safety issue, they pull the cord and the entire line halts.
Which sounds crazy to a traditional manager.
But the problem is fixed immediately at the source. That prevents defective components from flowing downstream and compounding the waste.
Okay, so if lean is stripping out the buffer and demanding speed, you have literally zero margin for error. That sounds terrifying if the tolerances on your machinery are loose. Does Six Sigma step in here to tighten the bolts?
It does. People always merge the two into Lean Six Sigma, but they aren't the same thing.
Yeah, I've always heard them smashed together as one phrase.
They are deeply complementary, but mechanically distinct. Lean removes the non-value added waste to increase speed and flow.
Right. Lean clears the road.
And Six Sigma ensures the vehicle drives in a perfectly straight line. It's a rigorous statistical methodology dedicated entirely to reducing process variation.
How rigorous are we talking?
It aims to reduce defects to a near zero mathematical probability. Specifically, 3.4 defects per million opportunities.
Wow. And variance in a supply chain context isn't just about a part being a millimeter too wide, is it?
No. Variance could be a supplier who takes 2 days to deliver a part 1 week and 5 days the next week.
And that unpredictability destroys a lean pull system.
Precisely. To mathematically hunt down and eliminate that variance, Six Sigma relies on the DMAIC process. DMAIC.
Define, measure, analyze, improve, and control.
Exactly. And this isn't just a basic brainstorming sequence. It is heavily data-driven.
Right, so you define the critical to quality characteristics.
Then you mathematically measure the current process capability.
Yeah.
You analyze the data to isolate the root cause of the variance.
Then you improve the process to narrow the statistical spread.
And crucially, you implement statistical process control to ensure human behavior doesn't drift back to the old, comfortable way of doing things.
The control part is huge. Okay, so we've covered the sledgehammer, we've orchestrated the network, stripped the waste with Lean, and eliminated the variance with Six Sigma.
Yes.
But you can't run a massive DMX project every time a minor hiccup occurs on the floor. How do you keep this highly calibrated machine running day after day?
That requires the wrench. Continuous process improvement, or what the Japanese call kaizen.
Kaizen.
It translates to change for the better, and it relies on small incremental steps.
But Kaizen isn't just a checklist, right? The text frames it as a fundamental shift in company culture.
It absolutely is. It requires empowering every single worker, from the executive suite to the loading dock, to act as a process engineer.
Which kind of democratizes quality control.
Exactly. The philosophy of Kaizen acknowledges that the person executing a task every single day knows the friction of that task intimately, far better than an executive analyzing a spreadsheet from an office.
So quality cannot be a top-down mandate?
Right. Kaizen builds a culture where workers are given the time and the authority to scientifically test improvements to their own workflows.
And the scientific method they use on the floor is the PDCA cycle, right? Plan, do, check, act.
The PDCA cycle prevents chaotic, random changes.
So how does a team actually execute it?
Well, they will plan by identifying a specific performance gap and hypothesizing a root cause. Then they will do a small-scale pilot test of a solution.
Just to see if it works without breaking everything.
Right. Then they check the measurable results against their hypothesis. If the data proves the solution worked, they act by standardizing that new process across the entire facility.
Honestly, finding the actual root cause for the plan phase seems like the trickiest part.
It is, because people naturally treat symptoms.
Right, like if a machine overheats, the symptom is heat, so someone might just put a bigger fan on it, but they never asked why it was overheating in the first place.
Which is why Kaizen practitioners rely on the cause and effect diagram, widely known as the fishbone diagram.
Ah, the fishbone.
When confronted with a problem, the fishbone structure forces a team to categorize all potential underlying causes across several domains, typically environment, people, materials, measurement methods, and equipment.
So you visually trace the symptom back through the bones of the diagram until you hit the actual structural failure.
Exactly.
I want to ground all of this theory in the anchor example from the CLTD text because it brilliantly illustrates the psychology of continuous improvement and a tool called value stream mapping.
Value stream mapping is incredibly powerful.
So just to define it, it basically visually charts every single step a product or service takes, ruthlessly separating the time that adds value from the time that is just waste.
Right, and the text applies this to a fresh produce logistics company.
Yeah, let's talk about them. This company was executing 4,000 deliveries a year to retail locations.
And during peak periods, they suffered from massive bottlenecks.
Right. Trucks were queuing endlessly in their own dispatch yards, severely degrading their delivery times and driving up overtime costs.
It was a mess. So management initiates a value stream mapping exercise. They track every minute of a driver's typical day.
And the data they get back is staggering. They discovered that drivers are only spending 60% of their shift actually driving or taking legally mandated statutory breaks.
And that 60% represents the only activity the customer is actually paying for, the value-added time.
Wow. So the remaining 40% of the day was pure Tim Woods waste.
Pure waste.
They found that 25% of a driver's time was burned just waiting at the customer's retail sites, like waiting for a dock door to open or for staff to unload.
But the most shocking revelation was internal. 15% of a driver's time was wasted just sitting in their own yard.
Which is insane.
It is. When they used the Kaizen approach to investigate why drivers were trapped in their own yard, they found layers of operational friction that had just become accepted as normal.
Yeah, like out of 4 fueling stations in the yard, 2 were permanently broken. That caused a massive daily choke point right there.
Furthermore, the bays specifically designated for dropping off reusable transit packaging were constantly blocked by random, misplaced warehouse equipment.
I love this example because it is the corporate equivalent of checking your smartphone's screen time data at the end of the week.
Oh, that's a great way to put it.
Right. Like you feel like you've been working hard all day, but the map provides objective proof that you spent 3 hours staring at a blocked drop-off bay or, scrolling social media.
The map forces management to confront the non-value-added time that they have simply gone blind to.
And once the value stream map illuminated the root causes, the solutions didn't require a multi-million-dollar digital transformation.
No, they didn't need the sledgehammer for that. They required a wrench.
They just fixed the fuel pumps.
They fixed the pumps, they implemented strict lean organization protocols to keep the drop-off bays clear, and they empowered the drivers with a streamlined reporting system.
So minor yard issues could be resolved immediately before they compounded into daily bottlenecks.
Exactly.
Yes.
It is genuinely incredible how much structural waste we accept as just the way things are, until a framework forces us to map it out minute by minute.
It really is. Whether you are an architect overhauling a global supply network or just a professional trying to optimize your own workflow, you absolutely need both tools.
You really do.
You need the sledgehammer to rethink the network from the ground up, and you need the wrench of daily Kaizen to prevent the new system from rusting.
Because true efficiency is never about blindly hacking away at costs.
No.
It is about understanding the mechanisms of your system deeply enough to remove the hurdles, preventing value from flowing seamlessly to the customer.
Yeah.
When you merge the vast visibility of an orchestrated supply chain with a workforce that is empowered to continuously improve it, you build an organization that can weather almost any disruption.
Which leaves us with a fascinating tension to mull over as we wrap up.
Oh.
Yeah. We spent a lot of time today exploring Kaizen and Jidoka, the concept of automation retaining a human touch, where empowered workers pull the cord and solve the problems.
Yeah.
But as we accelerate deeper into Industry 4.0, we are deploying artificial intelligence and machine learning algorithms that can analyze master data and rewrite their own processes in real time.
That's true.
So if the system is constantly running its own digital PDCA cycles at the speed of light, what happens to that human culture of continuous improvement? Does Kaizen simply become a background algorithm, or will a resilient system always ultimately require a human mind to pull the cord?
That is a very profound question to leave off on.
Something for you all to think about. Thank you for joining us on this deep dive into the APCS CLTD material. Keep questioning your processes, hunt down the waste in your own workflow, and we will catch you next time.